Hello everyone, welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Mandy Talvasto, and I'm a CNCF ambassador as well as Senior Product Marketing Manager at Camunda, and I will be your host tonight. So every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. They will build things, they will break things, and they will answer all of your questions. So join us every Wednesday to watch live. As well, if you want to host these kind of sessions yourself, on September 21st, the online programs calendar will be made for the next quarter, again available. So look forward to that. And this week we have Jason Morgan here with us to talk about locking down your Kubernetes cluster with Linkerd. Very exciting. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants as well as presenters. But with that, I'll hand it over to Jason to kick off today's presentation.
Oh, awesome. Thank you so much. Hey, folks. Hello and welcome. So today I'm going to talk to you about how we're going to lock down a cluster with Linkerd. So I'm going to show you how to set up MTLS. I'm going to show you how to restrict traffic so that only traffic in namespace works. And then I'm going to show you how to use the new HTTP routes that come from Linkerd 2.12 and the Gateway API, actually. I'm going to show you how to use that to specify by verb and by path what can happen. And hello, people from Raleigh and India, and hopefully other folks. I'm in Washington, D.C. It's great to meet y'all. Is it okay if I share some slides to start with?
Yeah, that's perfect.
All right, so just actually before I even do this, let me tell you who I am. I'm Jason Morgan. I am a technical evangelist for Buoyant, the company that makes the Linkerd project. And it's my job to tell folks how awesome Linkerd is and try to encourage you to use it. So today I'm going to be talking about locking down clusters. But before I say that, I really have to say, what is authorization policy and what am I talking about? Right. Well, the standard setup in Kubernetes, is to kind of allow traffic to and from any pod. The standard setup in Linkerd is to allow traffic to and from any pod, but with the caveat that when you're using Linkerd, you have MTLS everywhere. So authorization policy refers to how do we restrict who's allowed to talk to whom in your cluster, right? And we call it authorization policy because things that aren't authorized don't get to work. So let's go to the next slide here. For clarity, right, with Linkerd, we are using service mesh based policy to restrict traffic. So what does that mean? Well, it means that we need Linkerd in the loop, right? We can restrict traffic to pods that have the Linkerd proxy because that's how Linkerd does everything it does. We can restrict individual requests. So that is, we can go and say, hey, listen, this service account is allowed to talk to this web app on this port using this verb and executing this path. And yeah, we can do it in a very fine-grained way. And just a quick heads up, just so we're clear, what is authorization policy versus network policy? Network policy, at least when I think of it, I think of network policy as firewall. I think of application policy or service mesh policy as layer 7. So what layer are we operating at? With Linkerd, we use the workload identity, right? So just in general, in Linkerd, every pod gets its identity based on the service count that you configure in Kubernetes, and we'll show you a little bit of that when we get in the demo. It automatically includes encryption. It's enforced at the pod level, right? So because we've got the proxy running beside your application, we enforce it right there at the individual pod level. We can capture, so we use layer 7 language and layer 7 semantics, and hopefully you'll think after today that it's pretty easy. And that's actually all I'm going to do for slides. Just as a note, as we're going today, there's going to be a lot of stuff happening. The more you can interrupt me and ask questions and get clarification, I think the better this will go for everyone. So please feel free to interject whenever you can. And then for those who aren't aware, here's our Linkerd site. You can go to linkerd.io just to check out Linkerd, and we've got a getting started guide. If this is kind of over your head and you're not sure what I'm talking about, check out our getting started guide. It'll show you how to get up and running with Linkerd in 30 minutes or less. All right. So I want to kind of talk about what we're going to do today. So I've got a cluster, right? And it's running, it's got an application called Books app. It's got the Linkerd control plane, and it's got the Linkerd dashboard installed. And what we're going to do here is we're going to go to this Books app namespace, and we're going to set up namespace jail effectively. We're going to make sure that only things inside this namespace can talk to each other, with the exception that we will allow our dashboard to talk to our applications in this namespace so that we can get some statistics. I hope that makes sense. Great time to say something if it doesn't. And we're going to go do a demo, and I'm going to show you how that works. Okay. For reference, our Books app is broken up into 4 parts. We have a traffic generation service, we have a web front end, and we have 2 backends, authors and books, that power our site. All right, so I'm hoping y'all can see my terminal. Hello from Nigeria. Oh, awesome. I'm hoping y'all can see my terminal. At the top here, I'm going to actually be putting in commands. At the bottom left and bottom right, I'm just going to be showing you some watches. The bottom left here is just all the pods that are running in my cluster, because we're going to do some stuff, and I want you to see what's happening with our pods as we do it. The bottom right is going to be the current state of authorization policies. So what is authorized in Linkerd for the Books app namespace? So we're going to start. Our Books app pods exist, but none of them are part of the service mesh. That is, none of them have a proxy running beside them. We can tell this because when we look at them, they have one container per pod, and the proxy adds a second container. So for something to be in the mesh, you need at least 2 containers per pod. So let's fix that. I'm going to grab the deployment for the Books app, and I'm just going to add an annotation.
Yeah, there's a first question from the audience. So isn't something similar covered by Istio? If it isn't, what's the difference? Ask.
Yeah, great question. Let me go a little bit further, and then I'm gonna hop into that question. So first, let's get this running. I want to talk about what I'm doing here. So I get the deployment, and I'm going to add 1 line to each YAML manifest. That line is going to say linkerd/inject.enabled, right? It's just going to tell the Linkerd admission controller to go ahead and, or the Linkerd webhook to go ahead and modify these deployments. So let's do that. And while that's going, I'll answer your question. So now we see new pods are getting created, right? And they've got an additional proxy. So yeah, Istio and Linkerd are both now CNCF projects. They're both service meshes, and Linkerd, and they do some really similar things, right? The main difference being that Linkerd, well, hopefully you'll see with this webinar or this live stream, Linkerd is really easy to use. We also believe that we perform a lot better than Linkerd because we use a different proxy than Istio. Or we perform better than Istio because we use a different proxy. Okay, so we've got our app injected and it's running. Let's go ahead and just in another screen, I'm going to run a little port forward here. There we go. Jesus. We're just going to run a little port forward and we're going to take a look at our app. I'm running this locally. We can see that I've got an app. It's working. One thing that I have now that was pretty easy, right? And this is actually the start of our differences with other service meshes, is to get up and running with Linkerd, you don't need to use any custom resource definitions. Adding complexity or adding something like that. Yeah, so great question, Gaurav. Linkerd doesn't require you to use gateways, virtual services, anything like that, right? Like the core Linkerd just uses Kubernetes services and an annotation to set up MTLS, and we're off and running, right? So with no custom resources, my app still works. I can get some good statistics about it. So if I go back here, launch my dashboard, we can see some details about Books app. We can see how it works and how it's talking to the various components, which hopefully looks pretty similar to what you're seeing here. And we can get some details about what's going on in our environment. All right, back to the actual work of locking this down. So to start, what I've done is I've generated MTLS between all my connections. So even though we're allowed, everything in my cluster is allowed to talk to everything else right now. We can see when we look at our policies in the bottom right, we can see that, we've got two policies called default unauthenticated, one for the main route, one for the probe, right? The probe just being that health check. And we can see that nothing is unauthorized because it allows everything to occur all the time. But we're gonna change that right now. We can look at our deployment. We can see some statistics about what's going on, right? So this is just some high-level details about the traffic here in the Books app namespace. Going beyond that, right now we're gonna start getting into custom resources, and we're gonna start getting into advanced configuration for Linkerd. So the first thing I wanna do is I wanna set up a policy inside my Books app namespace that says your default behavior should be to deny traffic. We don't want anything to work unless we tell it to work. All right. What's notable here, let's actually go change what we're showing. What's notable is even though I turned on my default deny policy, I'm still seeing traffic flow through, right? The reason for this is the default policy for a given proxy is set at startup time for that proxy, right? So this is a really important caveat if you're watching. When you set default policy, you have to restart pods in order for that policy to take effect. So we can see that the pods are still running. Yeah, we can see the stats from the deployment. Sorry, I'm showing you that already. And now if I trigger a rollout restart, what we're going to see is all the apps get, we're going to see all the pods restart, and we're going to see all our traffic totally fall off and die. I just want to show you something really quick. If we look at our pods, right, one thing that if you use policy in Linkerd 2.11, you're going to expect different behavior than what you see here, right? So let's talk about this really quick. So we see all of our pods restart. That is because the default behavior in Linkerd 2.12 is to allow health checks to continue to exist all the time, right? Or except for in one very special case that we'll get to at the end. So it's going to keep your readiness and liveness probes succeeding, even though the app is receiving no traffic, right? One of the unfortunate consequences of this is we're going to see these things are going to slowly taper off to 0 and then disappear, and all of our stats from the dashboard for this app are going to die, right? They're going to disappear. So what's happened is we've told Linkerd deny all traffic, and we haven't authorized anything, right? So we've got our deny working great. All the traffic is down, and now we're going to need to authorize something explicitly so that we can get some traffic back. I hope this is still making sense. Folks in the chat, if you can give me the occasional thumbs up if you're getting it, I would be really grateful.
I mean, we did their question. So,
yeah, great timing.
Yeah,
so
does that mean if we are applying policies or with level policy all apps within the cluster, or and it needs to
yeah, so it does if you aren't prepared. So if you do this without knowing what policy without creating the right policy, you're going to take downtime, right? I'm doing this step by step in my example to show you how it works, but this can easily be a one-shot go where we apply everything immediately, right? And it all works. Policy, now when we first announced policy, like my boss, said loudly, this is the biggest foot gun we've ever given Linkerd users. This is a great way to create an outage with your service mesh if you're not careful about what you're doing. That being said, there is no requirement to take downtime to set up policy, right? You can actually do it You can actually do it all in advance and then go ahead and set something like a default deny. So what I'm going to do, I'm going to start allowing some traffic back, right? So the first thing I'm going to do is I'm going to create a server resource, right? So we've got a couple resources in play here. I think we're dealing with a total of 6 custom resource definitions that you have to deal with in Linkerd, right? So it's more than none, but less than 15, right? So it's not that big a handle to do. And again, you don't need to deal with this unless you're trying to add in policy. So we're going to create a server for our admin port. This is going to map a individual port in our application to an object that has policy applied to it, right? And I'll show you these YAMLs in a second. I'm just going to go ahead and apply them and get that started. So after I make a server object, I'm going to create a policy to start allowing admin traffic. So allowing Linkerd's dashboard to start understanding what's happening. So now that I've got this, we're going to start seeing some statistics come back, right? It's going to take a second, but we're going to see statistics come back because now we've authorized Linkerd to ask about the admin port. So let's show you what we did here. So first I created, let me make this a little smaller. First I created a server, right? What it did was it was looking for all pods in the namespace, right? So inside of its namespace, it was looking for any pod that matched any label. And it was looking for pods that had a port called Linkerd admin. And it told Linkerd that, hey, on that port, the traffic is HTTP2. So instead of having Linkerd trying to detect what the traffic was for this port, we just told it explicitly so that it's a little bit, it can do what it's doing a little bit faster. And then what we're going to do is we're going to apply a policy to this port. So let's look at that. So the next thing we do is create a policy, right? And what we're saying here is that for that server, if you're in the namespace books app, we want you to accept mesh TLS connections, and we want you to accept mesh TLS connections from our Linkerd Prometheus service. So that is the thing that collects the data, and then our tap service, which shows some cool metrics about what's going on in our app. Oh, we're not broadcasting. Okay. Cool.
We are broadcasting to YouTube, but LinkedIn is down.
Got it.
Or not down, but like, you know, we're not available there right now.
Okay, great. So that's what we did, right? So we've now allowed, let's go back to our diagram real quick. We have now allowed the Viz extension to talk to Books app. But right now, all of these links here are down. So they are all being denied by policy. The only collection from our Viz extension, from this Linkerd Viz namespace, is connecting in. And specifically, only the Prometheus and tap service counts are allowed to open connections here. That's why when we look at Linkerd, we have data, but there's not much going on here because our app's pretty empty. So let's show you what's next. So what I'm going to do now that we've got this, so now that we've got our initial stats working, we're going to go ahead and allow some in-app traffic. So what I have is I have 4 apps, right, and four distinct ports, right, 1 port per app, or actually 3 ports per app, because our traffic service doesn't actually accept any traffic. So we're going to tell authors, books, and web app. We're going to define a server that claims the actual application port on all of these instances. So we created one for authors, creating one for books, and we're creating one for our web app. They're all pretty identical, so I'm just going to show you one of them. And then after we create those, we're going to set up a policy that allows everything in our namespace to talk, right? Or only service accounts within our namespace to talk to other services. So let's show you how that's done. Right, so first off, what you're going to see now is some new things. Like, so right now, the unauthorized column, you're going to see those numbers start to drop, and you're going to see success rates and the request per second increase for actual authorized routes. Same thing on the left-hand side. We can see that our app is talking to itself. course, our app is broken. It's a demo app. It's broken on purpose. If you want to see more about how that works, I can send a link to a talk I did on debugging applications with your service mesh. So we've got some traffic going. So let's look at these objects. So first, we're going to look at the author server. So this is what's going to tell Linkerd, hey, listen, map to the application port on this application, right? So we give it some data. Hey, what are you? What namespace are you going to be in? How do you find your pod? Well, you look for a pod that matches the app name, authors, and the project books app. You're looking for a port called service, right? Like that's the name of the port that you define in your YAML manifest on your deployment. And then we give it the proxy protocol, right? Which we don't have to set, but I like to set it so that we can skip protocol detection. Once we do that, we're going to actually allow some traffic, right? So this is the part that I'm excited about. We say, we want a policy called books app only. What that means, and we want it to exist in the namespace. So we're going to say, if you are a policy target in the books app namespace, we want you to use this books app account's mesh TLS authentication, right? And this is the mesh TLS authentication object. So this is another new custom resource definition. We had servers for picking ports. We have authorizations for mapping policy to servers. And then we have two types of authorization objects. We have mesh TLS authorization for what service accounts should we allow to talk to this port. And then we have network authentication for what IP range should we allow to talk to this port, right? And we'll see one of those here in a minute. But what I've done here is I set an identity where if the identity of the workload certificate that is part of that MTLS connection that is auto-generated by Linkerd, but if the identity of that mesh connection, which is tied to the Kubernetes service count, matches anything within the books app namespace, we want to allow traffic on the application port. So every app can now talk to every app, right? Which is why we see traffic here. And if we go back to our diagram one more time, we can see, or we've got this link basically set back up. All right, so these apps can now begin talking to each other again. So we've restored basic traffic, right? So right now in what, 20 minutes, we've gone from nothing to MTLS between every single app inside the books app namespace, where we have only explicitly authorized connections between our apps are allowed. And if we look at our books app here, just going to restart my port forward. If we look at our books app, we can go like check out some of the books. We can view our authors, right? We can do whatever stuff we want. We can create a new book, create a new author. It's going to be me because why not? We can create a new author. That's cool. Add a book. Shoot, I should have thought this out. Thought this through. How to Linkerd. Page count 5. It's a short book, but a good one. Oh, doesn't work. That's okay. We'll fix that in a minute. But so we're able to create authors and do things within our application. I hope if you're watching, you're slightly psyched about this and you see that it's not a huge journey, right? Like going back to that object, right? Really, what did we do here, right? We created a policy that mapped the ports on or a server that mapped the ports on my various applications. And then we created a policy that said, if you're in the namespace, you can accept calls from any app in the namespace, any TLS app in the namespace. So nothing that's not TLS is going to be allowed in beyond health and readiness check probes from the kubelet. Nothing else is allowed in. So you've already drastically hardened this down. Cool. I'm hoping that's cool.
Works for me, but audience, if there's any questions, concerns, comments, anything, just send a message into the chat and we'll get them answered.
Yeah, if I get through this too fast, folks, you're in for terrible networking jokes and more slides. So up to you.
And there is a question you made, is the and a good review by some Archer saying awesome, so that looks good. But then there's also a question, is it possible to create stateful policies rather than stateful, similar to what a firewall does?
Yeah, would you be able to rephrase that? In general, Linkerd policy is not like IP based, right? Like that being said, we can specifically authorize calls from IP ranges, right? Like what we're doing with policy in Linkerd is validating the identity of a workload based on that mutual TLS that Linkerd bought us for our cluster, right? So when we set up Linkerd, when we put the proxies in, every proxy gets an individual workload certificate, and that workload certificate is tied to its Kubernetes identity. Mutual TLS means both sides of the conversation, like we have encryption between the pods, but we also have the identity validated for each workload. So we have the identity validated for each workload, and we can use that identity from the server side of the conversation to decide, should we accept this request? So Hassam, and I hope I said your name right, I don't understand what you mean by stateful policies versus stateless, right? Like these policies will survive application restarts, if that's what you're asking, right? It's just something that you store in the Kubernetes API, and that Linkerd or the Linkerd proxy will check on when it authorizes a given request. But I'm happy to dive in more if I missed. Oh, I clearly misunderstood. So if you can explain it to me in a different way, I'm happy to dive in more. Okay, so now that we have that, right, let's lock it down even more, right? So our author service, if we decide our author service, hey, this is a really sensitive service. So going back to our little diagram, we're okay if traffic talks to web, and web talks to authors, and authors talks to and books talks to authors, all that stuff. We're okay, right? But what we want to do is we want to make sure that if you're talking to authors, only certain accounts are allowed to do things. So we don't want traffic talking to authors, and we specifically don't want it. We want to specify who can do what on what port. So we're going to create some policies that use HTTP routes, which are Linkerd. Oh, sorry, let me step back. Linkerd 2.12. Another big part of what we did is we're beginning to adopt the Gateway API specification, which we're really excited about. There's great work coming out of the Gateway API group, and we're using HTTP routes to actually build policy for Linkerd. And as we look at what we're doing next with Linkerd, we want to continue to use Gateway API specifications to do that. Okay. So let's go back to our demo. So let's isolate authors, and I want to show you a little bit about our first kind of edge case. So when we set up what we saw originally when we built these connections is that all of our pods stayed ready because by default Linkerd respected or set a default exemption for liveness checks and readiness checks. We call them probes, right? But when we set up HTTP policy, you have to explicitly, or HTTP routes, you have to explicitly authorize it. Hold on, I'm going to change this. So now I just want to get the pods in the Books app namespace. So let's take a quick look at it. So we're going to create a route for authors, and we're going to create a policy. And you know what? I didn't do this right. So give me one sec. I just want to show you what we did here. We created a route that is sorry, folks. Let's just look at this object. So this is the thing that I created. And once I created this, right, we saw the author service go from ready to not ready, or one of our pods, our application pod, became unready. Right, and what happened is we when we create an HTTP route, it overwrites the exemptions that we make for health checking. Right, so let's just take a look at this route really quick. So we see this route. It defines what server it applies to. So it's using that previously defined author server, and it's saying like, hey, on either of these paths, you can do stuff. But when we created this route, we didn't also create the exemptions for the probe. So we're going to have to fix that next. So let's create a probe exemption. So here I've got a new document called authors probe. Let's actually look at that, which will allow the health check probes to pass. So we're going to create this, and then we'll talk about what we did. The authors probe here, it creates a route that specifies that health check address, which if you look at the YAML manifest for our app, /ping is our health check URL. And that creates a network authentication policy, right? And it maps that network authentication policy to that route. So what we're saying is, hey, listen, if you're not in the mesh, but you have any IP address that the cluster could possibly have, we're going to let you hit that health check URL, right? And this is our mapping object that actually builds that. I hope this makes sense. We're going to hide this now. And after we created that, we saw that the author service became healthy once again because the kubelet was able to check in on that ping address. Now beyond that, right? Let's actually go look at our app again. Now beyond that, if we go look at an author now, right? If we want to add a book, new book, pages 1. Right, we're gonna get a failure, right? Because right now our web app is not allowed to do a get. So we only authorized a get. We didn't authorize a put or a delete, right? So only one verb is allowed. So only the get verbs are allowed. So we fail when we try to update it, right? So we're going from coarse grained, right, where we open up the name or we lock down the namespace, to really fine grained on just the author's application, where by verb, we're setting a different policy, okay? So let's keep going. So we're gonna allow things to modify the route. And again, I should show you what this actually looks like. So let me fix that. When we look at the modified route here, right, what we're gonna see is, we're going to say, hey, listen, for things that use this route, you're going to be able to do deletes, puts, and posts on these applications or on these paths inside of our web app. And when we create it here, we see that our modify route gets created. Right. That being said, we still don't have.
Yeah, there's.
Oh, Martin, that's a great question. I'm going to get to that just as soon as I'm finished here. Thank you so much for sharing that. Sorry, I didn't mean to speak over you there.
No worries.
So now that we've created the route, we're going to actually apply a policy so that something will like attach that route to our server and set some rules here. So we're going to create it. Let me show you what we did again. Right, so we took that route that we just created, that modify route, which that's kind of a redundant name, but whatever. We said, hey, listen, restrict yourself to whoever's mentioned here in authors modify authentication, right? And specifically what we're saying is we're going to allow the web app to do this and only the web app. So books isn't allowed to use puts or deletes or posts, right? Books is only allowed to do gets. Make sense? I hope that makes sense. And that is the end of our demo.
Exciting.
So yeah, what we did here over the last 35 minutes, right? Just to clarify, we took our app that was working. We didn't do anything to adapt the app to our service mesh, right? So the core belief in Linkerd is that if you have an app and it works in Kubernetes, you should be able to add it to Linkerd and it still works with no changes, right? And try getting that deal with any other service mesh. On top of that, you get MTLS and statistics about what's going on. Then we showed you not just how to add MTLS, but to take that namespace and say, bam, absolutely nothing that isn't explicitly authorized will be allowed. That's what we did with that. That changed the proxy behavior to default to denying something unless it's authorized. Then we went in and we took our apps and we said, okay, for the Linkerd admin port, that is the proxy admin port across this whole environment, we're going to allow connections to the proxy admin port from the Linkerd visualization dashboard, right? So that we could get, our fancy metrics about what's going on, right? And our fancy details about the environment. So we could do things like tap the live traffic and see who's talking to what, right? In our cluster, and what the performance is of these various components, right? Or go look at books. There we go. And books isn't receiving a lot of calls, so that's not really that exciting. But you get the gist of it, right? It's what allows us to get these statistics. Then beyond that, right, we showed you how do we allow application traffic to all things within the namespace. So we set up a policy that said, hey, listen, star.booksapp.servicecount. Whatever, right? If your identity matches anything in the Books app namespace, we're going to allow you to do application traffic. So right there, we had a little box around our namespace that protected us from anything that wasn't in the namespace traffic. Even Linkerd now, if it tries to connect to the web server on one of these pods, it's going to get denied because we didn't authorize it, so it's not going to happen. If we add an ingress, right, which obviously you'd want to do if you wanted to share the traffic, you'd have to explicitly authorize the ingress, right, to that port. And you can do it by changing that, adding another like under star.booksapp, you had service in namespace. And we decided that we had a very sensitive service, and only books and web talk to authors at all, right? Do any, and then one app would be allowed to make changes to our author's database. Right? It's kind of about it's an easy app, but it's not to do this across a bigger environment. Like anything, test, go in steps, right? I forget who asked earlier. Let's see if I got this. Somebody asked if we had to take an outage. Oh yeah, I think it was Gaurav. Asked if we had to take an outage doing this. No, you just have to plan. You have to plan, you have to prepare, you have to test, right? And
Great.
yeah.
Would now be a good time to get to Martin's question? Or
yeah, absolutely.
So Martin asks, in your experience, how much does the percentage consumption of a given deployment increase when Linkerd proxy is injected? Yeah,
so Martin, great question. So we actually care a lot about the performance of Linkerd, right? Just to go broader, right? Linkerd, our intent is to be the easiest to use, the fastest, and the most secure service mesh on the market. I believe those things are true, not only because I'm paid to say that, right? Like I actually believe, but you can test for yourself and see what you feel. We did some benchmarking of Linkerd versus another popular service mesh, and we have some statistics about what exactly is the memory, CPU, and latency footprint of Linkerd when it compares to something else. So I'll give you a sense, but you're really only going to see what it changes when you actually deal with your real app. Because like no two apps are the same. Like we're doing a benchmarking harness made by the folks at Kinvoke. It's a generic service mesh benchmarking thing. One set of numbers, but real application data, real application traffic is going to impact the performance and the resource utilization of your proxies. I hope that was a good answer for you, Martin.
Yeah, so let's hope so. Martin, if you want to know something more, of course, ask more and we'll get the answer.
If you liked any of this, is it okay if I do my little plug now?
Yeah, of course.
All right. If you liked any of this, feel free to come do an in-depth search and production workshop. While it's not that complicated, it's really get a sense of all the pitfalls you might run into before you run into them. It's happening the day before KubeCon. I'll be there. There'll be other people. You can say hi. Hat, if you haven't seen our hats. They're pretty cool. So lots that you should join. On top of that, if you haven't seen it, we're doing a bunch of folks are doing a little conference right before KubeCon as like a warm-up. It's free. It's online. Check it out. Called KubeCrash. Hope to see you there. Sorry. And last but not least, if you have thoughts on this, you want to say hi, you want to be like, oh, Jason, Istio is the best. Come join me on the Linkerd Slack and tell me what you think and why. And I'd love to hear from you and love to see what things are you working with and see if there's any way I can convince you to run Linkerd in production.
Perfect. The hat seems really cool. I think everyone should be lining up to get one of those now. Sounds really great. But yeah, we had the link to the benchmarking as well as the Slack now added to the comments, so everyone can go hop on over there to check those out. But don't obviously leave it quite yet, because you still have your chance to ask your questions if you have anything for more here for our speaker. So ask the questions away. We still have a bit of time. Yeah, anything else that you want to add now, Jason, to before we hopefully have a lot of questions coming in, or let's see.
No, only big one. I just want to send you the getting started guide. If you haven't seen it, like, I promise you can get through this in 30 minutes. Like 30 minutes is a long time to get through it. Linkerd is easy to use, right? Like I started out believing, when I came into Kubernetes, I was working with, another vendor, another space. And, I believed that service mesh was really complicated and really painful. And while it was valuable, you had to be really good to use it, right? Like Linkerd is straightforward. It's simple. It's fast. Go through the getting started guide, right? Like if you can't get through it, like I'll see you at KubeCon, I'll say sorry, right? I'll buy you a beer or whatever, a non-alcoholic beverage, whatever your preference is.
Yeah, makes sense. But it is very fast. I've done it a few times, so it's always very nice. Yeah.
Awesome. Thank you.
Cool. Yeah. But to kick off the Q&A, a question from me. So while we see if anyone else has any questions, do you have any kind of sneak peeks? What's in the future for Linkerd? Is there anything exciting coming up or anything?
Yeah, fantastic question. Thanks for asking. So we're really excited about the Gateway API and what it allows us to do, right? So Linkerd's philosophy has been to really limit the number of custom resource definitions we add to your cluster. The reason we do it is we believe that for every custom resource definition you add some element of complexity to the environment, right? The Gateway API becoming, potentially part of core Kubernetes gives us a lot of really powerful tools for manipulating traffic, for doing traffic splits, for setting up things like retries, timeouts, header-based routing, egress control, all sorts of great tooling in a standard Kubernetes native way. So with the next release, so Linkerd 2.12 just came out not that long ago. I don't remember exactly, but it came out in August. And it's been really cool, and it gives you a lot of new functionality. We're working diligently right now on Linkerd 2.13 because we want to do a small release next that adds in something that a lot of folks have been asking for, specifically circuit breaking and header-based routing, right? So we're excited to see what's going to happen there. We expect to get that out. We expect to get that out this year. And yeah, I'm really looking forward to it. And I think that it just adds more power to an already pretty powerful tool.
Perfect. Sounds really
we
cool.
Like useful standards, right? So like some standards can end up adding more, they can on occasion do more harm than good. this Gateway API standard seems really good. So we're really optimistic.
Great. So final call for questions. If anyone is typing away right now, please push enter and send as soon as you can. But as always, though, if you realize later on, like, oh, I should have asked that question or that, obviously you can hop onto the Linkerd Slack, or you can also hop on over to the Cloud Native Live Slack and CNCF, and then you can the Kubernetes CNCF Slack, so you can find out from there as well. You know, here's the little join our live chat on the CNCF Slack there. You can hop on over there. But I think probably the Linkerd Slack is the best for Linkerd direct questions as well. So everyone has a lot of resources on there. On their way. So perfect. But yeah, since no questions, at least I can't see currently, we had already a lot of questions throughout the session, so we handled the Q&A during that, so that was lovely. Do you have any final words, Jason, or anything just before I wrap up?
I do, actually. Check out, if you like this, but you want a much longer in-depth version, check out our Service Mesh Academy site. Next week, I think next week or the week after, we're going to do a really deep webinar into policy in Linkerd, done by my colleague Flynn. He's awesome. It's going to be similar to this, but better and with more information. So check it out if this was good at all.
Perfect. We had Flynn a few weeks ago in Cloud Native Live as well, so people might be familiar with him from there. Yeah, and we had a good review as well, so great session and everything. But yeah, let's start wrapping up. So thank you everyone for joining the latest episode of Cloud Native Live. It was great to have a really good session about locking down your Kubernetes cluster with Linkerd. Really loved the audience interaction this time as well. Thank you for all the questions. And as always, we bring you the latest Cloud Native code every Wednesday, so stay tuned. We have a lot of great content coming up in the coming weeks as well. So thank you for joining us today, and see you next week.